continuing on with section 6.6, going through the graphing section. So we've been talking about plotting points and how there's no magical certain things that you have to pick for your t-table. And we practiced some of those on the last video. And where we left off, we had y equals 3x minus 2, and we'd made a t-table for it and found 7 points that worked for that. And this is what your graph should have looked like to check your work there. So the next note would be, notice that each line that we've graphed so far has a certain slope or slant on it. This one's a little steeper maybe than some we've graphed. We can think about this steepness, this slope, as the rise over run. Slope of any line, slope which is the rise over the run of the graph. How much from point to point, how much does it go up before it goes over? And you can take any 2 points on the line to figure this out, like from here to here. I have 2 points plotted, 0, -2, and 1, 1. I chose those 2 points. So the rise would be from this point to this point, 1, 2, 3 up, so I'll call that +3, and then 1 over, run of +1. So we could say the slope of that line would be 3 or 3 over 1. And any point that I picked, if I had some other points, if I went from any 2 points to another point, the ratio would be the same. It has a ratio of 3 over 1. Okay, another way of thinking about that again is the steepness. They also use the letter m for slope in math. I don't know why. You can Google that and get some ideas, but anyway, m equals slope in math. And it's always the rise over run from point to point. Another way of saying it is it's the vertical change, so how much it goes up and down, which will be the rise, over the horizontal change, the left-right change. And we have a formula for that. If you have the picture, you can just count rise to run from point to point. But if you don't have it graphed and you're just looking at 2 points, you can figure out the slope by subtracting the y points over subtracting the x points. So if you have 2 points given, for example, let's just do that. If I had a point 1, 2 on a line, not this line, so I'm just making up some points, and a point 3, 5. Those were 2 known points on a t-table given to you as a problem. It said find the slope between these 2 points. You would subtract the y values. So think of this as being an x1 and y1. It's the first point, and this is the second point, x2, y2. So you would subtract the y2 minus y1, it says, so 5 minus 2. Then the x's, x2 minus x1, 3 minus 1, and you would have 5 minus 2 is 3, 3 minus 1 is 2. The slope would be a fraction 3 over 2, rising 3 or running 2 from point to point. Now, just to note, you could actually rearrange your points and consider this point 1 and this point 2. You just need to be consistent in which way you subtract. If I go 5 minus 2, I need to go 3 minus 1 for my x's. I could also have said 2 minus 5, but then I need to do 1 minus 3. It works out the same because you get a double negative there, so it reduces to the same answer, 3 over 2. So no, you can really go either direction, even though the formula sort of makes it seem like not. It is inferred, because who's to say which one's point 1, which one's point 2? You can go either direction, but just be consistent with your x's and y's. Okay, so in general, let me review. There's 3 methods for graphing a line. We have been definitely working on the point plot in the last 2 videos. Just picking arbitrary, notice it says pick at least 3 arbitrary values. I kind of chose some for you so we'd have the same ones to practice on, but it could have been anything. A lot of students take 0, 1, and 2, which is fine. So any 3 points, really only 2 required, but 3 is just a check on yourself. Plug in for either the x or the y and find an ordered pair. Plot those points, connect your dots, that's your line. Point plotting. The second method specifies using intercepts. Now it's really another version of point plotting, but it just specifies, let's make sure you plot the x and the y intercepts, the zeros. So sometimes your directions will specify you have to graph using the intercepts. So it's the same thing we were doing just whenever you make your t-table. On my markers, okay, now when you make your t-table, you'll want to plug in x is 0 and y is 0. do the zero value specifically when it says to use the intercept method. And then it's a good idea to find one other arbitrary point to get your 3 points to check on, and then connect your dots. All right, on the next page, the third method for graphing a line is using the slope-intercept method. I should not have erased that. Y equals, let's see, that's 3x minus 2. All right, so follow along with me here. It says if you're using the slope-intercept method, you write the equation in y equals mx plus b form. And this one just happens to be a good example of that. That just means it's solved for the y variable. It's got y on the left side, one positive y equals the rest of it. If you solve an equation for y, what you'll see, again, it's called the y equals mx plus b form. Notice that the slope, remember we said stands for slope, shows up in front of the x. And we said that earlier when we tested this with the formula, the slope of this line was 3. Well, we also would have known it by this method. Anytime you got y equals blank x, that is your slope. Now this other number behind it, b, is your y-intercept. So we can graph a line. I kind of like this method. I think it's a handy way to graph a line, maybe a little quicker. You don't have to do as much algebra, especially if it's already solved for y. If it's not, you'll have to do that part. But that means you can take the y-intercept, which would have been -2 on this, plot that. It's a known point. Again, the last number is the y-intercept. Start here. That's where you cross the y-axis. So plot the y-intercept -2, and then this will be your slope, which is your rise over run. If you don't see a number there, the run is 1. It's understood 1. So from this point, rise 3, run 1 gives you the other point, and then you can draw the line in that way. So before I go on to your special cases, well, let me go ahead and just say that, and then we'll do some practice problems. All right, special cases then. Let's say that. The special cases, A, if you have a linear equation, some x and y, and it can have numbers in front of it, and ax plus by equals 0. If your equation, whatever your x and your y are, equals 0, that means your graph is going through the origin. So when you try to do the intercept method, the intercept's going to be at the same place. The intercept crosses through right at the origin every time. So it doesn't have a unique x-intercept, y-intercept. They are one and the same, the origin. So you will have to pick another point if you're going to graph that. You'll only have one point given. But you'll know anytime, say it's 2x plus 3y equals 0. That graph goes through the origin. 5x minus 2y equals 0. That graph goes through the origin. 2x plus 7y equals 0. That graph goes through the origin. So that's one known point. Now if you're going to graph it, you're going to need a second point. You're going to need to take one of these methods. So you know it's got 0, 0. 2 times 0 plus 7 times 0 equals 0. But you need another point to show the uniqueness of it. So maybe plug in x is 1 or something else. You'll need to plug in another point, get a y point, and then graph your line. All right, so that's one thing just to be aware of. Sort of a shortcut there. Then the other two, the horizontal and vertical lines. So B part, horizontal lines, they have a slope of 0, they're flat, they go left and right, flat lines, happen whenever the x has a coefficient of 0. If you don't have an x variable, you just have like y equals some constant, y equals 3. It's like having 0x plus 1y equals 3. And if you made a t-table for that, you'd find out that it just goes flat, left to right through the 3. So that's a horizontal line. Horizontal lines always have a slope of 0, flat line, flat ground. All right, C, the vertical line. Vertical lines, straight up and down lines, happen when the y variable equals 0. So you have something for x plus 0 for y, 0y, say equals what I do here, equals 3 again. So whenever the y variable is missing because it's 0, and you just have x equals a constant, you can make a t-table and show this as well, but it's going to be straight up and down through that number. So 1, 2, 3, and straight up and down. Now the slope of a vertical line, and we could show it by taking 2 points off that line. but the slope is undefined. You get a 0 in the denominator of the fraction when you try to do this one, so the slope is undefined on that. All right, now we're just going to practice some problems. So now we'll just get into the kind of practice phase of everything we've said here. So again, please pause the video to practice these, and then come back in with me and I'll go over each of these. All right, so our first example, and it does not say what method to use, so I'll try to mix these up a little bit so we'll get some practice with each method. But if your directions don't specify the method, then you're free to plot your points, or do the intercepts, or to use their y equals mx plus b slope intercept method. So that's really your call if the directions don't hold you to a specific type. And so I have not here, so we're just going to see what do we think is best. If it's already solved for y, I like the slope intercept method. When you've got y equals mx plus b, that's your slope or your rise over run, and that is your y-intercept. So I like to graph with that method. That's where you start here, and notice it's positive 4 on your y-axis, your y-intercept, and then rise over run from this point up to over 3. And then that drawing your line from there. Again, start here at positive 4 on your y-axis, and then rise over run from this point up to over 3. And then it's done. It's a little quicker, I think. We'll do that again on example 2. Example 2, we also have a y equal, so it's already solved for y. So this is a start here at -3, and again, that's your y-intercept. Don't get it confused with your x. This is your y-axis. This is a y-intercept. So go down 3 on the y-axis, then rise over run. Now notice this one has a negative sign on your fraction. You can use the negative on the rise or the run, but don't double use it. Just put it with one of those. It's up to you. I'm going to choose to put it with the top and say a rise of -1 and a run of +2. So from my intercept, rising -1 is actually going down 1, and then run +2 would be right 2. And then that would draw my line. Notice that negative slope lines go this way. I'm not sure we've done one of those together yet, but a negative slope line will be going downhill as we read from left to right, a negative slope. So notice that. Again, that's your y-intercept, and then the slope is -1, so down 1 over +2 over 2. All right, number 3. And note that you don't have to use this method. You could point plot. I should probably do that method as well to remind you. I will on this one. So on this one, let's say you want a point plot. You can plug in 0, 1, and 2 if you so desire to. Plug in 0 for x, 2 times 0 plus 1, y equals, I should say. That's y equals 1. Then do it again. Plug in x is 1, 2 times 1 plus 1. That will be y equals 3. Plug in 2 for x. So y equals 2 times 2 plus 1, which is 5. So then I can plot those 3 sample points. 0, 1 would be right here. Over 1 up 3. And then over 2 up 5. So you can plot with point plotting as well. The only difference with the intercept method is I would have needed to have plugged in 0 for y. Let me demonstrate that. If I plug in 0 for the y side, I have to do a little more work on this one, just the way it lays. So 0 on the y side, I have to throw the 1 across the line, divide by 2, and the the x-intercept is -1/2. So it looks about right. I'm crossing the x-intercept at about -1/2. So your intercept methods, if it specifies, you must use those. The newer method that I said I think is a little quicker is the slope intercept method. If it's solved for y especially, you're looking at the slope and the y-intercept. You start here on the y-axis, so +1 on my y-axis, then rise 2, and that's understood to be over 1, right? So that would have plotted a little quicker. All right, I think I'm going to have to pause the video and do the rest on the one more section.